Okay, so for the given graph, we need to write two formulas, one in terms of sine and one in terms of cosine. So let's go ahead and start with our sine function. Maybe we'll be able to use some pieces of information for both. I go from 5 to -1, so that means my midline must be at 2. Okay, so then I know that my k should be equal to 2 for both my sine or my cosine function, whichever one I choose, because the midline is the same for both of those. Okay, cool. Also, I think the value of the amplitude itself will be the same for both graphs. So if we compute the amplitude, that should be 5 minus a minus 1 over 2, so that should give me 6 over 2 over 3. So then I think our a is equal to 3, we can say for sure. Okay, and now we may have to think about where a sine function would actually start. Typically, if you think about a sine function, it would normally start kind of right here. So it looks like we also have a phase shift going on. And if I kind of drop this down, it looks to be between 0 and 10 pi, about exactly halfway in between. So it looks like that we may have had a phase shift of about 5 pi. And this is for our sine function. Okay, so it looks like it's been shifted over at about 5, by about 5 pi. Okay, so now we need to find the period of our graph. And so this one's actually, it's nice to do peak to peak or valley to valley, because down here I can see that I start at 0 and I go all the way to 20 pi before I repeat. So my period here should be 20 pi. Okay, so then if we put all that information into our formula for sine, we should get y equals, our amplitude was 3, sine. Okay, now we need to find out what our b is, because I think we know everything else. Our x, we said our phase shift was 5 pi, and it was 5 pi to the right, so it should be minus right there. And then we also said that we have a shift up of 2. Okay, so how do we find this b value? Well, we know that our period equals 2 pi over b. Okay, so then we should have that 20 pi equals 2 pi over b. So if we solve for b, we should get that b is equal to 1/10. Okay, so then for our sine formula, we can kind of fill that in. Okay, perfect. So we have 3 sine of 1/10 x minus 5 pi plus 2. Okay, now let's move on to cosine. Okay, now for cosine, I think our k is going to stay the same from our midline, and our amplitude is going to stay the same. So our a is still 3, k equals 2 from before. And I also think that our period is going to stay the same too. From peak to peak, that's not going to change if we are looking at sine or cosine differently. They have the same period anyways. So I think our period is still 20 pi. So therefore our b is still 1/10. So now I just think we need to think about our phase shift and where we may have started for cosine, or where we regularly start. Cosine normally starts at the peak, which would be right here, but I also noticed that I have a peak down here, so you could either do this next part, you could either do it as a phase shift or a reflection across x. I think I'm going to go ahead and do a reflection across x, because normally cosine would start at its peak, but here it looks like we've flipped it. And so if we reflect across x, we should return back our original cosine graph. So let's go ahead and do that. So we'll get y equals, if we're going to flip it, we need a negative out in front. So we'll have -3 cosine. And then since we're flipping it, instead of doing a phase shift, we'll just leave our 1/10 in our parentheses all by itself. and then it should be plus 2 still. Okay, perfect. So then our formula for cosine is negative 3 cosine of 1/10 x plus 2. Great. All right, now we're going to look at 25, and we have the high and the low temperatures on a sunny day. I'm going to use a cosine function because I like to avoid phase shifts. Okay, so I'm going to use cosine, and then I notice that it's kind of starting exactly where it needs to, save for it's flipped. It should start up here. So there should be no horizontal phase shift if we're going to use cosine, so that should be 0. Our amplitude, we can find that because this should be 103 up here, and this down here should be 69. So to find our amplitude, we'll do 103 minus 69 over 2. That should give me 17, so that's equivalent to our amplitude. Okay, so A is 17. All right, and then our period, we can see from valley to valley that our graph repeats every 24 hours after 3 a.m. So our period is 24, and then we know 2 pi over b is equal to our period, or 24, so we can solve for b to get that b is equal to pi over 12. Okay, then our midline, it'll be similar to our amplitude, but we're going to add this time, so it'll be 103 plus 69 over 2. That should give me 86. For the midline, and that will also be the value of k that the graph is shifted up. Okay, so if I put that all together, I also have I'm going to note that I reflect across x. Okay, so then if I write my equation, I'm going to have negative 17 cosine of pi over 12 x plus 86. Okay. You could also do this with sine. It'll function fairly similarly. You might just have to employ a horizontal shift. Okay, now you're given the graph of a company's sales, and we need to find the highest sales and the lowest sales. So we know that our amplitude is 43.2, and if our graph weren't shifted up any, we know that the lowest point of our graph would be at negative 43.2, and it would go all the way up to positive 43.2. But our graph has been shifted up by 68.7, so we can just add 68.7 to both of these values to find what our lowest and highest would be. Plus 68.7 plus 68.7, and so then my graph will reach a high of 111.9, and over here we'll get 25.5. So our highest sales will be 111.9 thousand, and our lowest sales will be 25.5 thousand. Okay, great. Okay, next we'll look at number 27, and we need to find a formula for this graph, and we know it has a minimum at 0 and a maximum at 3 pi over 8, 5. So we can choose either sine or cosine. Again, since this peak is along my y-axis, I'm going to go for cosine and then just reflect it across the x-axis, and that should result in a regular cosine graph. You could also do a phase shift. I just like to do reflections. So first, I think we'll need to find our amplitude. So our amplitude should be our 5 minus 0 over 2, which is going to equal 5 halves. So we at least know the first part of our formula, and then we said that we're going to flip cosine so that the peak is up at the top, because that's how it normally looks. Okay, so now we need to find the period of our graph. So this graph should be symmetrical about this y-axis, so I can go ahead and assume that this is at negative 3 pi over 8, 5. And so then I can go ahead and calculate my period, so I'll subtract these two. It'll be 3 pi over 8 minus 3 pi over 8, which should give me 6 pi over 8, which is the same as 3 pi over 4. So then I know that 2 pi over b gives me that period, equals 3 pi over 4. So then we can solve for b to get that b is equal to 2 pi divided by 3 pi over 4, which the pi's are going to cancel, and this is the same thing as saying 8/3. Okay, great. And then lastly, we just need to find our midline, which will be equal to our k value. And lucky for us, our midline is going to be the exact same as our amplitude because our minimum value is 0. So 5/2 should be our k value, or our midline. Okay, so we can go ahead and put together our equation. Negative 5/2 cosine, and we said that b was 8/3 times x plus our k value of 5/2. Okay, perfect. Alright, so now we're given this little problem, 28, and we need to find the period of the functions shown. We know that right here is 21, so I'm just going to look at how many different cycles we have. So right here we have 1 cycle, then from here to here we have another cycle, from here to here we have 1 cycle, okay, and then from here to here we have 1 cycle, so this will be about a half of a cycle right here. Okay, so then we have 3 1/2, so that's 7/2, so I have 7/2 periods, and that happens when x is equal to 21. So what I think I'll do is divide my length of 21 by the 7.5 periods that occur, and that should give me that we have 6 periods that occur in this function.
So for this problem, we are told that we're given a tangent function that passes through the points negative 2 pi 7, 0, 5, and 2 pi 3, with asymptotes x equals 4 pi and x equals negative 4 pi, and we're told to find the values for a, b, and k in f of x equals a tangent of bx plus k. So the first step we're really going to need to do for this problem is to refer to what the regular tangent function looks like. Okay, so now let's look at our original tangent function here on the right. So one thing that we'll notice is that our tangent function is flipped. So this is essentially flipping it over the x-axis, which means that we'll have a negative value in front of our tangent. So our first thing we're going to say here is that we have a reflection. Okay, so what else do we notice? Well, we notice that we would normally have a period that goes from negative pi over 2 to pi over 2, which is a period of pi. But now our period goes from negative 4 pi to 4 pi, meaning our period is 8 pi. And so we actually have a formula for period in terms of our b value based off of this. So we know that our period is pi over b. Okay, and we said that our period is 8 pi. So our period is 8 pi. So 8 pi equals pi over b. And then we're going to multiply both sides by b. So we multiply both sides by b. We get b times 8 pi equals 8. Equals pi. So b times 8 pi equals pi. And therefore, if we divide both sides by 8 pi, we would get b equals pi over 8 pi, which means that b equals 1 over 8. So we know b equals 1/8 over 8. So, and we could say that our second transformation here is a horizontal stretch because our period is going from pi to 8 pi. So it would be a horizontal stretch by a factor of 8. Okay. So now we have our reflection, we have a horizontal stretch. What other things do we notice about this graph? Well, normally we have the middle of our tangent as 0. So for each of these periods, we have the center point at 0. But in our case, we have a center point here on the graph, which they give it to us at that point is 0, 5. Therefore, we have a vertical shift of 5. So our graph is going up 5. So vertical shift of 5. And since we have a vertical shift of 5, we know that that means our k value is 5 here. Okay. And lastly, we need to figure out what our a value is. So we know our a value is our vertical stretch or shrink. And in this case, the way that we can find that is using those points they give us. So you can see we have points negative 2 pi 7 and 2 pi 3. So just looking at the graph, we can tell that negative 2 pi 7 is this leftmost point, and 2 pi 3 is this rightmost point. So where would these points be on our original tangent graph? Well, if we look at our tangent graph, we have a point here and a point here, which are usually known. So since we know that tangent of pi over 4 is 1, because that's where our sine and our cosine are equal, then this point here is pi over 4, 1. Likewise, we have this point in the third quadrant where we would have negative pi over 4, negative 1. So now that we know these points, let's compare these to our function. So we know that our graph is shifted up. So our graph is shifted up 3, meaning we would have a midline right here at 5. And so since we have a midline of 5, and then we're going up to 7 at that point, that means we're going up 2 here. Similarly, we're going from our midline at y equals 5 to a y equals 3 here, meaning we're also having a distance of 2. So since this distance from our midline to these points are now 2 instead of 1, that means we're essentially multiplying our y values by 2, or we have an amplitude of 2. So we would say we would have a vertical stretch of 2. So those are all of the transformations that we have to our tangent function. It's important to note that whenever you're doing the stretches, you do your horizontal stretch before a horizontal shift, and you would do a vertical stretch before a vertical shift. So these ones would actually be swapped if you're writing them out. But anyways, so we have all of these factors to consider now, and now we get to use those to write our equation. So, let's write our a value. So since we have a vertical stretch of 2 and a reflection, that means our a value is going to be a negative 2. So we're reflecting it around the x-axis, and then we're stretching it by a factor of 2. So our a value here is 2, and therefore our final equation is f of x, that's our y, equals negative 2 times tangent of 1 over 8x plus k, which is 5. Okay, for this problem, we're told that for the graph of f of x equals 3 tangent of pi over 8 times x minus 2, find each of the following. So first, let's just write out what our equation for tangent is with transformations. So we have f of x equals a tangent of b times x minus h plus k. So looking at the equation that they give us, we know that our a is 3 because that's in front of our tangent. Our b is what's in front of our x, so that's pi over 8. Our h is 2 because that's what's being subtracted from the x. And then our k, well, there's no k there, so our k is actually 0. So now let's relate this to our problem. So looking at part A, we're told to find the period and phase shift for f. So for a period, we actually have a period formula. We used this on the last problem. So that period formula is period is pi over b. Okay, so we just said that our b value was pi over 8. So our period is pi over 8, which is essentially pi over 1 divided by pi over 8, which is the same as pi over 1 times 8 over pi. So crossing out the pi's, because they're going to cancel, we would get a period of 8. So for A, we know that our period equals 8. Now, how do we find the phase shift? So our phase shift is actually just our horizontal shift. So in this case, we have a horizontal shift of 2 because h equals 2. So our phase shift, or our horizontal shift, is 2. So we're going to call that phi. So phi equals 2. Okay, for part B, we're told to name any two vertical asymptotes for f in the interval from -10 to 10. So that means we can find any vertical asymptotes for which x is -10, or anything in between -10 and 10, or 10. So just looking at what the original tangent graph should look like, let's say our tangent graph looks something like this. And then we have asymptotes at pi over 2, negative pi over 2, etc. So that's what our original tangent graph looks like. But now we have these transformations. So we know that the only transformations that are going to affect these asymptotes, since they are x values, are our horizontal stretch, which is our b value, and then our phase shift, which is our h value. So applying this b value, or our period here, we know that our period is 8. So instead of having a period of pi, our period is now 8. So if these asymptotes were at pi over 2 and negative pi over 2, they would instead be at 4 and -4. We know this because we have a period of 8, and so to the left we go 4, to the right we go 4, and then in total we have 8. So instead of having these asymptotes at x equals negative pi over 2 and pi over 2, we would have our vertical asymptotes at x equals -4 and x equals 4. However, that would be the case if we only had that horizontal stretch. But we actually have a horizontal shift too, which is our h value. So since we're shifting by a factor, we're shifting right by 2, these x values are going to move to the right 2, meaning they're going to get bigger by 2. So instead of having a horizontal asymptote at x equals -4, that would be x equals -4 plus 2, which would be x equals -2. Likewise, instead of having that asymptote at x equals 4, we're shifting it to the right 2, so we're adding 2, and then that's therefore at x equals 6. So you could keep finding more of these horizontal asymptotes, since we know that our period is 8, so if you move to the right of x equals 6, you would also have a horizontal asymptote at x equals 6 plus 8, which would be 14. However, that is not within the domain they listed, because they're telling us to look between -10 and 10. But we could look to the left of our x equals -2 asymptote, because if we move to the left 2, or if we move to the left 8, we would subtract 8 from the -2, and we'd have x equals -10 as our other asymptote. And that would fall in this domain. So the options you have here would be x equals -10, x equals -2, or x equals 6. Okay, for problem 31, we're given the function -4 tangent of pi over 2x plus 1, and we're told to find the period, vertical stretch compression factor, if it's reflected about the x-axis, and then shifts, and 4 asymptotes. So looking at part A, we're told to find the period. So maybe let's go back to our equation for tangent. So for tangent with transformations, we would have f of x equals a tangent of b times x minus h plus k. So we know that our a is negative 4, our b is pi over 2, our h is just 0, and then our k is 1. Okay, so for our period, we know that our period formula is pi over b. So our period is pi over 2, which the pi's will cancel and the 2 will flip to the top. So we'll actually just get 2 here. So that's our period. So for part B, we are asked to find the vertical stretch / compression factor. So we're looking for things that affect the y's essentially, which in this case is just whatever's in front of the tangent. So in front of our tangent, we have a negative 4, but we're just looking at the magnitude of that. Or if it was a negative, it's a positive. If it's a positive, it stays positive. So in our case, our vertical stretch / compression factor is 4. So we would have a vertical stretch, because this number is greater than 1, we'd have a vertical stretch of 4, or by a factor of 4. Okay, so for part C, it's asking if we have a reflection about the x-axis, yes or no. So since we have a negative in front of our tangent, that's going to tell us that we're reflected around about the x-axis. So for C, we would say yes. For D, it's asking if we're shifted up, down, left, or right. So for those, we're going to be looking at our h and k values. So we have no h value, meaning we don't have any horizontal shifts. So we don't have any horizontal shifts. So we're not going to be shifted left or right. But for being shifted up or down, that's where we look at our k value. And since we do have a k value there, we're shifted up 1. So up 1. So now let's look at part E, where they ask us to find 4 asymptotes. So for E, let's kind of try and sketch what this graph is going to look like. So we know that since it's shifted up 1, and our normal tangent graph starts at 1, we're going to hit 0, 1 on our graph. And since it's reflected about the x-axis, we know that instead of seeing a regular tangent graph that looks kind of like that, we expect to see something that looks more like that. Okay, and we also know that we have a vertical stretch by a factor of 4, so where we would normally have a point at pi over 4, 1, and negative pi over 4, negative 1, instead of having those negative 1 and 1s, we would expect to have 4 and negative 4 for our y values. So we would still have pi over 4, except we also have a horizontal stretch here. So remember how we have our pi over 2, or our b value, in front of the x. So that's going to stretch our graph. Fortunately for us, we found the period earlier, and we found that our period was 2. So that means from our middle point to the left, there will be negative, or we'll be going 1 over, and from our middle point to the right, we'll be going 1 over. So we would actually have asymptotes at negative 1 and 1. And this is because our period equals 2. Okay, so our 4 asymptotes that we could say would be x equals negative 1, x equals 1, so what we just determined. So let's say this is kind of what our graph looks like. Okay, and since we know that our period is 2, that means we'll have asymptotes every 2 in the x. So we're at 1, so we'd also have 1 at 3, we'd also have 1 at 5, we'd have 1 at negative 3, and negative 5. So some of our asymptotes we could pick would be x equals negative 5, x equals negative 3, x equals negative 1, and x equals 1. But you could also pick x equals 3 and x equals 5. So if we were to finish this graph, we would end up with something like this. Mind my sketching. And just like this. We don't have to find this for the problem since they don't ask us to draw the graph, but it is helpful to see. Let's now look at problem 32, where we're asked to find the period for each of the following functions. So for part A, we have a tangent graph, and we know that for a tangent graph, our period is pi over b. What is our b value? Well, that's what's in front of our x. So our b value is 1 over 8. So our period is pi over b, which is pi over 1 over 8, which is 8 pi. So now let's look at part B. So what's the period of a cosecant graph? Well, it's the same period that we would have for a sine or a cosine graph, which is 2 pi. So that means our period formula is 2 pi over b for a transformed graph. So what's our b value? Well, it's the same as how we would find it for the tangent graph. It's whatever's in front of our x. So that's 2/3 here. So we would have 2 pi over 2/3, which is the same as 3 pi, because the 2's are going to cancel and the 3 is going to flip up. So in this case, our period is 3 pi.
Okay, we want to find the vertical asymptotes of this function, a secant function. And on a normal secant function, asymptotes occur at pi over 2, and then again at 3 pi over 2. So to find where these asymptotes are for this graph that has a different period, we can set the inside of the secant graph, which is pi over 6 times x, equal to the known asymptotes from the original graph. And then we just have to solve for x. So here, x is going to be 3. And for the next one, x is going to be, it'll be 18 over 2, which is 9. So now we know that x equals 3 is an asymptote, x equals 9 is an asymptote. Also, x equals -3 is going to be an asymptote because the regular secant graph looks like this. There's an asymptote at the same place on the negative side of the graph. Okay, for this problem we have a cosecant graph, and we want to find what the value of k would need to be to make it look like this graph here. So first thing, we can do it the same way we approached the last problem. We can look at one of the asymptotes, and this is at 4, but usually if we hadn't shifted, like if k was equal to 1, then that asymptote would appear at pi. So we can put in our kx equals, normally it would be pi, but now we know that x is 4, so k times 4 equals pi, so k must have to be pi over 4. Okay, so for 35, A, B, and C, we want to simplify these trig expressions down to a single trig function if possible. So let's start with A. We have tangent theta, cosecant theta. So first let's just write those as what they are in terms of sine and cosine. So tangent is sine theta over cosine theta, times secant, or cosecant would be 1 over sine theta. So those guys will cancel out. So we have 1 over cosine theta, which is secant theta. So this first one is secant theta. Next we have part B, which is 1 minus cosine squared x, 1 plus cotangent squared x. So we know from identities like sine x plus cosine squared x equals 1. This first one, 1 minus cosine x, is just sine squared x. And another identity is 1 plus cotangent squared x is cosecant squared x. So this is cosecant squared x. And then we can write cosecant in terms of sine. So we have sine squared x times cosecant is 1 over sine squared x. So those will cancel each other out. We just get 1. Okay, part C, we have cosine x plus sine x all squared minus 2 cosine x sine x. So we can like FOIL this out like we would a polynomial. Just because it's sine and cosines doesn't mean that we can't still multiply like we would. We get cosine squared x plus cosine x sine x plus cosine x sine x plus sine squared x minus our 2 cosine x sine x. So those guys cancel with that guy. We get cosine squared x plus sine squared x, which is 1. Alright, for problem 36, we just need to fill in the blanks to make this left side, secant of negative x minus cosine of negative x, look like the right side, which ends up being sine of x times tangent of x. So, first thing we can do, let's look at this cosine function. Cosine of negative x is the same thing as cosine of x. So we can write this as secant of negative x minus hold on. What about the secant? The secant, it's the same thing, because secant is 1 over cosine. So if this rule applies to cosine, it'll also apply to secant. So secant of negative x is just secant of x. So now we have it simplified to secant x minus cosine x. They did the next step. They changed the secant into 1 over cosine x. So we'll do the next step. Well, let's go ahead and look at what they did after. Looks like they combined the two into one fraction. So we need to find a common denominator between those 1 over cosine and our cosine. So we'll change our cosine of x into cosine squared x over cosine x. So now we have a common denominator. So this right here will be 1 over cosine x minus cosine squared x over cosine x. And then you can move into this next step that we talked about. Okay, now what do we need to do? Well, let's remember that identity sine squared x plus cosine squared x equals 1. So 1 minus cosine squared x would be sine squared x. So this is going to be sine squared x over cosine x. And then you can break that up into sine and sine over cosine, which is sine and tangent. So there we go. Okay, number 37, we want to turn tangent of t and put it in terms of sine. So we can only have numbers and sine in our answer. And we're going to be in where t is between pi over 2 and pi, so that's going to be in quadrant 2. So we'll just keep that in mind for any sine things that we run into. So let's start off with tangent of t. How can we write that with sines? Well, tangent is sine t over cosine t, but now we have a cosine, and we don't want cosine, but kind of a theme with this page, we have that identity that we've been using, sine squared x plus cosine squared x equals 1. So then sine squared x equals 1 minus cosine squared x, but we want just sine. Sorry, we need to solve this for cosine, not sine, because cosine is what we want to replace. So cosine squared x equals 1 minus sine squared x, and then we can take the square root of both sides. So cosine x is going to be plus or minus 1 minus sine squared x. So that's where our quadrant 2 thing comes in. So in quadrant 2, cosine is negative. So when we took this square root, we would have had a plus or minus on this side also, and it would have been the minus that stayed around. Now sine is positive, so on this side it'll be a positive, but we need a positive cosine, so cosine x equals negative the square root of 1 minus sine squared x. Now back to where that comes in our problem, we want to replace this cosine with this thing down here. So our tangent of t turned into sine of t over cosine of t, and that cosine turns into minus the square root of 1 minus sine squared t. Now we only have numbers and signs, so that is going to be the answer to this problem.